yeah, that's what we want to present you today, a little bit about the insights into the vehicle that we show there. And you already see it up here. That's our vision. So our vision is to have sensor integration into autonomous vehicle roofs with sunroofs, a panoramic sunroof, much light and comfort in the vehicle to drive you safely and comfortably from place A to B in the future without any steering wheel in it. So what's needed for that? We'll give you some insights, and Marcel is going to tell you about necessities for autonomous driving.
Yeah, thank you for the handover, Michael. So also welcome from my side. I'm happy to be here. It's my first time at the Plug and Play, actually. And yes, as you can see behind me, environmental sensors like lidars, radars, ultrasonic sensors, and cameras are required to detect the environment if you want to enable automated driving functions. So you can basically say those sensors assist or replace the eyes of the driver. The camera, for instance, can detect other traffic participants, like you see here, traffic lights or pedestrians. And based on the input of those sensors, the vehicle computer can derive the next driving actions. So speaking of the lower levels of automated driving, those sensors usually have their fixed installation location. The camera, for instance, is usually placed behind the windshield. But now if you want to increase the amount of sensors because you also want to increase or optimize your automated driving functions, you also need additional installation locations. And here's where the roof becomes a good choice. And if you know your way around the automotive industry, you can't get past the name of Webasto. And this is why Bosch and Webasto met in 2019 at an informal dinner and decided to exhibit a roof prototype with an integrated sensor module. This was just the one Michael showed on the slide before. And yeah, from this kickoff, cooperation has developed so far where every party brings in their strengths and is working on a very startup way on this topic of the roof sensor modules. And with this, I just will hand over to Michael again, who will now give you an overview about the potential and advantages of the roof sensor module.
So when we're looking at the market now, so a couple of years ago, we were only talking about sensor integration in the roof. Now, these vehicles that you see up here, all those varieties are announcements, what we will see on the roads in the next 1 to 3 years upcoming. Some of those vehicles, especially the Neo and the Psych, are already on the roads in production now. And going towards the right side, coming from level 2 via level 3, the sensors get more and more. So coming from one to several sensors that are integrated in the roof in a sleek and compact way towards level 4 autonomy. The number of sensors get more and more to even vehicles that will look totally different in the future. So all these vehicles upcoming, we'll see these vehicles on the road in the next years. Globally, it's like from all regions what we see here. Now that we know that we need the sensors, next slide please, we need to understand why is that actually. So coming from a vision point of view, there's a reason why we have the eyes in our head and not in the knees. So the higher, usually the better. That means for a vehicle to be able to understand situations like we see on the top left there, complex traffic situations in cities, at highways, you're making a left turn, somebody's coming with 150 kilometers per hour, the vehicle needs to see that if you don't have a steering wheel anymore, and you're not going to take that view. So that's what the vehicle will need to see for all kinds of situations to understand. Next point then is soiling. So we want to drive or being driven in an autonomous vehicle in any weather conditions. If it's snow, if it's rain, if it's mud, dirt, dust, if we are driving in dark or light conditions. So what we need is to be able to operate under any soiling conditions, may it be mud or the snow that you have in the lower parts of the vehicles. The upper part of the vehicle is less influenced by that. So the higher, the better, again, from that point of view. Third one is it's less affected by risk of damage. So bumper crashes, vandalism, all that, even stone chipping is a much less risk if you go to the roof and have the sensors in the roof. All that brought together, the roof is the location where you can have one module one module where you can see everything 360 degree that's placed into the vehicle and the production line of the OEM. Next slide, please. So coming to production, this vehicle you will see on the road next year, SOP in 2023. A retractable roof module where we have a LiDAR sensor popping out of the front of the roof in a vehicle in China. You may know the brand Lotus from Geely, and this is what we are just having in serious development. We are dealing with the mechanical integration, the mechatronic integration, the kinematics to pull it out and in. A cleaning system is integrated. We're dealing with the thermal aspects to keep it in operating condition. And last but not least, of course, most important, the appearance, to have automotive grade, nice and sleek appearance. Looking further in the future, next slide then, we need more sensors. So we still want to keep sleek, sunroof integrated with more sensors. There is, in that case, 5 sensors in the roof. So that's the vision we are going to make it nice and have a great customer experience for autonomous vehicles in the future. And for full autonomy, you will need even more sensors, up to 25 sensors, which Marcel will give you an insight onto what we're seeing there in the prototype vehicle.
Yeah, thank you, Michael. So the result of the collaboration so far, you can see here on the slide or at the booth in the back of the building. And yes, what have we done? We have integrated 25 sensors from Bosch. But next to the sensors, there's also a cleaning system that uses air and water jets to keep the optical sensors clean. And besides that, there's also a thermal management system that makes sure that the sensors are operated at a constant temperature, which also brings a lot of advantages to the operation of the sensors. And all this thermal technical equipment is integrated in a very confined space, as in this car there's also an openable panoramic roof integrated for the well-being of the passengers. However, this vehicle is not only for demonstration purposes, it is also a joint test vehicle. And because regarding the cleaning of the sensors and therefore the increasing the availability of the sensors, there are a lot of open questions. And to answer all of these questions on the road under real-life conditions, we have equipped this vehicle with measurement technology for the sensors, but also for the thermal management and the cleaning system. And yeah, so we're working in a very agile way together, and we are also evaluating and testing together, more or less depending on the expertise of the company so far. Now I just want to give you a short overview about the sensor set. So as I just mentioned, 25 sensors have been integrated there, and still amazes me how stylishly the sensors are integrated into the roof. And we have tried to integrate as many sensors as possible. The view of there are 16 cameras in the forward and backward direction. We have integrated cameras that are usually used for far range detection. And on the side of the vehicle, we have integrated some cameras that are more for the near field detection. The same applies also for the radar sensors. And in each corner, we have placed one LiDAR. And with this sensor set, you can cover for each sensor modality a 360-degree view. You can see it on the slide, and I do not want to go into detail of every sensor, but I just want to point out the camera because due to the amount of 16 cameras, it's the most dense coverage of the vehicle, especially in the front where you have to detect traffic lights, other participants in the traffic, but also you need to have some lost cargo detection, so you need to detect objects in the far range. And with respect to our cooperation, this 360-degree view is very helpful because now we can evaluate and test the cleaning functions for different sensor positions under different driving conditions. And now Michael will also give you some insight where else we have some activities going.
So yes, exactly. With all those vision of the sensors, they need to be kept free of sight under any circumstances. So that's why we add a lot of features into the roof in addition to just placing the sensors and let them see. They need to see in any weather, in any light condition. So we had a cleaning system cleaning to keep it free with water jet, with air jet, and many new innovative technologies for cleaning. And we're working actually with some startups for that, also via the Plug and Play here. We've been with Plug and Play for a couple of years now, and some of the technologies already are being considered here. De-icing function needs to be added for melting snow or ice in winter conditions, and in summer conditions we need to cool down the sensors to keep them in their operating range. As the sun is shining, the sensors, similar to a laptop, is producing heat, and we need to cool those components. And last but not least, to have pedestrians also recognize the vehicle is running autonomously there, we're adding an ADS light, so-called autonomous driving signal light. Many of these technologies where we're looking into and working with startups already, also via Plug and Play. And best chance here for the event, come to us, come to the booth, talk to us if you have any ideas or solutions to help us there to bring this on the road into serious production very soon. Thank you very much.
Yeah, thanks all from my side.
And great to have you here.